Hey guys. So I just wanted to continue our conversation about easy general trinomial factoring. So again, we talked about this in class. We said the trinomial, that means it has to have 3 terms. We said the easy part means the leading coefficient must equal 1. Again, leading coefficient means it's the coefficient or the number that's multiplied by the variable that has the highest power. So even if it's not in order, the leading coefficient is go to the variable that has the highest power and take its coefficient. So if we looked at something like 9x squared plus 3x plus 2, this is the this is the highest exponent. That variable has it, so this is the leading coefficient. Just so happens that it's first, but I could have them in a different order. So let's say if we did negative 11x minus 14 plus 12x squared. Again, I look for the variable that has the highest exponent. That's this guy. So this is the leading coefficient. So in an easy general trinomial, that leading coefficient must be 1. So neither of these is an easy general trinomial because its leading coefficient is something other than 1. We're looking for something like x squared plus 3x plus 2. All right. The term that has the highest power, its coefficient, it's not written there, so it's an implied 1. All right, so it has to be a trinomial. The leading coefficient must be 1, and this idea of general is that it's the exponent pattern. All right, the highest term, or the highest exponent, must be double the middle exponent, and the other term can have no variable. All right, so again, we looked at something like that in class. If we did x to the 50th plus 3x to the 25th minus 9, right? I'm looking at the pattern of the exponents. So the highest one is double the middle one, and then that other term, that last term here, can have no variable. All right, so this would be a trinomial. Its patterns put it in the form of being general, and then its leading coefficient is 1, so this is an easy general trinomial. All right, so let me just give you a couple here to see if they are easy general trinomials or not. And let's say we did all right, so let's go through these, say yes or no. So is this an easy general trinomial? Hopefully you're saying no because it's not a trinomial. Again, it has to fill all of these requirements for the easy general trinomial. The leading coefficient, yes. The general part doesn't follow because the middle term or the middle variable isn't half as big. There is no other variable and it's not a trinomial. So this is no. This one, it follows the general part, the x squared, and then this is an x to the first, so that's half. And then this has nothing with it, but then it's not easy. This is actually going to qualify as a harder general trinomial. Right, this one Hopefully you say no. It is a trinomial, but it fails on two parts. One is the easy part. Again, the leading coefficient is not 1. This, if we look, this exponent is 3, this one is 1, so this is not double this. All right, so this is also, these are both no's. This is a no, because it's not a trinomial. This is an easy general trinomial. It's written in the wrong order. We would need to rewrite it as x squared plus 2x plus 3, but notice that it's a trinomial. The leading coefficient is 1, and the exponent here is twice as big as the exponent here. All right, so hopefully if you still had any questions at the end of class today, that clears things up. All right, so let's just talk about what is going to give us an easy general trinomial when we multiply it out. So let's take something like x minus 8 and x plus, well, let's start with x plus 8, x plus 4. And let's just multiply it out using FOIL like we did before. So we're going to do x times x. I'm just going to write these for right now like that, right? This is plus 4 times x. This is plus 8 times x. And this is plus 8 times 4. Oops. All right, so when we multiply these out, we get x squared plus 4x plus 8x plus 32. And then we combine like terms here, and we get x squared plus 12x plus 32. So I just want to point out that this x squared came from the product of these two first terms. So the product of the firsts. All right, where did the 32 come from? Well, let's trace back. It came from the 8 times 4. Those are the two last terms. So this came from the product of the lasts. And then where did that 12 come from, or the 12x? Well, it came from, it's the sum of these two. All right, so 8 plus 4, and then we just had that x. So this comes from the sum of the lasts. All right, so we get this constant here, which was the product of the two last terms, and the 12x, which is the sum of the two last terms. Again, we've got that x in there too, but if we're just talking about the coefficient, this came from 8 plus 4, and this came from 8 times 4. Let's do another one. So let's say we have, oh, and one other thing I want to point out is that this is actually an easy general trinomial. So obviously the trinomial. The easy part is that our leading coefficient is 1. And then the general part comes from this being double, this one right here, and this not having any x term at all. Right, and notice that the form here was an x, and then we had two numbers right here. All right, let's try another one here. So let's say we have x minus 9, x minus 6. So again, we're going to multiply it out. X times x gives us x squared. X times negative 6 is negative 6x. Negative 9 times x is negative 9x. Negative 9 times negative 6 is positive 54. We combine like terms. We get x squared. Here, we're going to get negative 15x. And here, we get positive 54. All right, again, if we go back up here and we look at where these numbers came from, this 54 came from the product of the two lasts. Again, product of the lasts. And this is the sum of the lasts. All right, if we add negative 9 and negative 6, we get negative 15. All right, let's do another one. Oh, and again, we'll confirm it's an easy general trinomial. It's a trinomial. Its leading coefficient is 1, and this highest exponent is double this. We could even do one that was, let's say, x squared minus 9 times x squared minus 6. I just want you to see what that looks like. So if we do x squared times x squared, we get x to the fourth. If we do x squared times negative 6, we get negative 6x squared. Negative 9 times x is negative 9x squared plus 54. So we get x to the fourth minus 15x squared plus 54. Again, these are the same numbers as before, but I just want you to see that we get that pattern again, where this exponent is double this one, and there's no variable right here. So as long as these two match, and they have a leading coefficient, and they both have a coefficient of 1, we should get an easy general trinomial, even though these won't be the typical x squared, x to the first, but they'll still have that pattern of this being double this one. All right, let's look at another one. I'll go back to the x to the first, but this time I want to do x to the first plus 3 and x to the first minus 7. All right, so our first one, both of the terms were positive here. All right, both of our constants were positive, plus 8, plus 4. When we added them together, a plus 8, a positive 8, and a positive 4 gave us a positive 12. And a positive 8 and a positive 4 gave us a positive 32 when we multiplied them together. Here when we did a negative 9 and a negative 6, when we added them together we got negative 15, and here we got negative 9 times negative 6 equals positive 54. Let's look at when we multiply a positive and a negative constant together. So here we get x times x, x squared. X times negative 7 is negative 7x. 3 times x is positive 3x. And 3 times negative 7 is negative 21. Okay, so that's what it simplifies to. Now let me take a look at this negative 21. I multiplied negative 7 and negative 3, so this is still, and I got a negative 1, this is still the product of the lasts. All right, got a negative 21 here. Now let me look at this one right here. That still is a sum of the two middle terms, or the sum of the two lasts. I said it was the sum of the two middle terms. I mean the sum of these two right here, but they came from adding these two together. All right, but notice in this one, when we did negative times negative, we got a positive here, and when we did positive times positive, we got a positive here, right? This one we did positive times a negative, and we got a negative here. All right, let's try another one, except let's make the negative the smaller one. So let's say we've got x minus 6, x plus 9. Right, x times x is x squared. I'm not going to draw the arrows. You can still continue to do that, but it gets to a point where you just can remember which ones you've done. So x times positive 9 is positive 9x. Negative 6 times x is negative 6x. And negative 6 times positive 9 is negative 54. Right, again, it's still an easy general trinomial. This right here came from multiplying the lasts. And this right here is the sum of the lasts. All right, so negative 6 times positive 9 is negative 54, and negative 6 plus 9 is positive 3. So notice that when we have opposite signs in here, that we end up with a negative constant at the end. Opposite signs, because we're multiplying a negative times a positive or a positive times a negative, we end up with a negative constant. And when we do a negative times a negative, like in here, we get a positive, or in this last, in the very first example, a positive times a positive, we get a positive 32. So we can say, if I give you something like this, x squared plus 6x plus 7, well, that's not going to work. How about plus 72? I can say, oh, that's positive. If this factors, this had to be either both positive to get a positive 72 or both negative to get a positive 72. All right, see that? If I did two positives here, I would multiply together to get a positive, or if I did two negatives, I would multiply together to get a positive. But then I would say, well, they would have to add together to give me a positive 6. There's no way that two negatives could add together to give me positive 6. So if it's going to factor, it has to look like that. Or if I gave you something like x squared minus 7x plus 12, again, I would say, well, if this factors, positive 12 means it's got to be either negative times negative or positive times positive. But then I look at this and I say, well, I could add two negatives together to get a negative, but I can't add two positives together to get a positive, so it would have to be that. So we're going to start deducing things about what these factorizations must look like. But for right now, I just want you to see that the middle term comes from adding the two constants here, or the two last terms, and the constant comes from multiplying the two of them. All right, we'll work with signs next week, but for right now, I just want you to see the pattern that it ends up being that is the product and that is the sum. This is the product, this is the sum. This is the product, this is the sum. So we'll keep doing that, but for right now, that should help us get set up for factoring these in class on Tuesday. Bye.